getting ready for our half of chapter 11 in geometry test. In problem number 1, this has to do with section 11.1, and this was all about circumference and arc length and finding portions of a circumference. What number 1 is getting at is that we have an angle in here, x. What was the measure of that degree, x, if the arc length wound up being 13.7 meters? And so the way that I've got to look at this one is that some angle x out of 360 times the circumference, which is going to be 2 times pi times the radius of 7, that all equaled this 13.7. So the x is in a weird spot. We just have to find what that unknown angle is. And the way that I handled this problem in my calculator, the easiest is to go and take this entire group in parentheses, 2 pi r, and I'm going to divide both sides by this first, and then I'll deal with that 360 in the bottom. I'm going to divide both sides by 2 pi r, 2 pi times 7. I'm going to cross it off on the left side. X over 360 is equal to, and I have a feeling this is going to be a pretty small number, like a small decimal. So when I go in there and do this, yep, 13.7 divided by that is about 0.3115. And once I get to that, I've got that number in my calculator. My next step to find the angle would be, let's multiply by 360 and get it out of there. I know I made this problem look a lot easier, as I should have, but we had to go find the missing angle. When I multiply that small amount by 360, I get back to that angle. I'm going to write it as about 112 degrees. So that 13.7 was 112 degrees, that fraction of the whole circumference, and we found that whole circumference this way. So section 11.1 did problems like this. There's one like each of these on your test. Just so you know, the first 3 questions on your test tomorrow are like each of these. Number 2, actually 2 is the easiest. What fraction of the circumference? So you start out, petty course. Yeah. Okay. I'm in the middle of something. You're welcome. Cool. Fraction of the circumference. In number 2, we know that the angle is 83 degrees. So 83 out of 360 times the circumference, which is going to be 2 times pi times the radius. That's going to give me the arc length. This one was straight up, this fraction of that arc. And so when I go and do all these on my calculator, and I'm always wrapping parentheses around fractions in these groups to make sure that all the order of operations is done correctly, I'm getting about 5.8, and that would be centimeters for problem 2. And again, I'm wrapping parentheses around things. Number 3 has a missing circumference, but what we know is that 48 degrees, that fraction of this circumference, works out to be 8 centimeters. That fraction of this circumference works out to be 8 centimeters, and what they want is the circumference. I'm just going to go and divide by this 48 over 360 and drop it in parentheses to do that. Divide by my 48 out of 360 in parentheses. I'm getting 60. The circumference must have been 60. What was our units? Inches. It is. That's the circumference formula in here. This one was, he's asking about this. This is the whole circumference, fraction of. Again, on your test, you're looking at things like this. In addition to this from section 11.1, degrees to radians, radians to degrees. I will provide you with the circumference formulas. I'll provide you with the conversions for degrees to radians. Number 4 really had 2 problems. It says convert 26 degrees to radians. So number 4, I've got to go degrees to radians. And when I look back, that means then I have to multiply that by pi over 180. And so that's going to be 26 pi's over 180. Pull a math frac on that, and just let's reduce the 26 over 180. Did this before. Just pull a math frac on your numerical values in the fraction. And that one is reducing to 13 pi's over 90. Now, in number 4, we also have take radians to degrees. That is 5 pi over 9 times, remember it's the reciprocal, 180 over pi. In the top, let me multiply my numbers together. I'm getting 900 pi. I feel like we had this problem before. Divided by 9 pi. Well, this one's reasonably easy. Pi's cancel out. 900 divided by 9 is going to leave me with 100 degrees. So from section 11.1, you'll be given circumference formulas and radians to degrees conversions. On your practice 11.1, on your practice 11.1, you know, focus on those 6, 7, and 8 problems at the bottom, and then the practice that we did with these conversions. So for 11.1, make sure you've got those things covered. Going on to section 11.2 and finding areas of a sector. So now section 11.2 is all dealing with finding fractions of areas and areas of circles. In number 5, the red sector was the 100 degrees out of 360. What's the area? That's going to be pi times 12 squared. So on that one, anybody have that? 125.7 approximately. What units are we in? What kind of yards? Yep. So that fraction of the area is that. Now in 6, they want the area of the blue sector. The blue was the other part of the shaded. That's the remaining 260 degrees of the circle. So actually, I can just go back into my calculator and do a, you guys ever do second enter? It brings your problem back and then you can change stuff. Like I'm changing the numerator. I got 326.7 for that. Oops. 326.7 yards squared for that. So if I added these two together, I'd have the area of the whole circle. That's both parts of the circle. If I put together red and blue, it'd be the whole. Good stuff. I wanted to make sure that section 11.3. Yeah, for section 11.2, that's what you see here. Let me see, 11.2. I'm gonna look real quick at your practice. Yeah, pay closest attention to the 7, 8, 9, and 10 on 11.2. Yep, 7, 8, 9, and 10. Bless you. Now, section 11.3, good stuff. There's a problem just like this. It's broken up into a lot of different parts. Like it's numbered like 7 through 12 or something, but I'm gonna tell you guys it's just like this. So, first things first, it says in 7, what is the center of the circle? The center of the circle is C. Name a radius of the circle. I could give you CR or CY. Just name one that's actually drawn. You know, don't draw in a new one. I could draw in a bunch more radii, but I'm not going to. Name one that's actually drawn. An apothem. There's only one that's named, C to Z. And a central angle. This is a pretty deep problem when you think about it. If this is a chunk of this problem, or if this is a test question, there's a lot going on here. How many sides does this have? What's the central angle then? 360 divided by 8. Cool, 45 degrees. Now, number 9 looks so innocent, doesn't it? Number 9 looks so innocent. It says the radius of a circle is 8. Oh, nuts. I got excited for 9. Let's do 8 first. Hold on. What was that apothem? Okay, and the radius is 8. I got that there. Find the measure of. Okay, so central angles are all 45. All right, I'm just going to kind of do this to remind myself. Now, so number 8. Find the measure of. I got excited to do the area. This is a test question too. Don't miss it, because I know you're going to get so excited to do the area. RCY, let's see, RCY, that's one piece of the pie, 45 degrees. measure of RCZ. Let's see. RCZ. That's going to be half of a piece of the pie. 22.5. The measure of ZRC. ZRC. Now, for ZRC, I'm just going to kind of draw it right here. I would do the same thing. CRZ. They want ZRC. What's this angle right here? This one's 90. This one's 22.5. And so ZRC is going to be the other 90 degrees of the triangle minus 22.5. What's that going to give us? 67.5 maybe? 67.5 degrees. I have a feeling we might use this triangle here in a minute for number 9. Yeah, perfect. Let's use this triangle right now for number 9. Well, I'll show you how in a sec. So 9 is, now I'm excited, find the area. So in order to find the area, remember the formula is, and I'm going to give you this formula, apothem times the number of sides times the side length all over 2. Right now, we don't know an apothem. We do know the number of sides is 8. And we don't know a side length either. Now, if I go and consider that I just took that piece of the triangle off, that's there, then what that means is this is going to be my apothem. This is going to be my radius of 8. That was given to me. And what I'm going to do right here is name this X, and remember as we do this, X is representing half a side. Now there's multiple ways that we can go do this. You can get at these answers, but no matter what, you have to start with trig. You have to use sine, cosine, or tangent in order to solve this, because you have 2 unknown lengths. Let me just go along and find, why don't I just find the half a side length? So related to the 22.5 degrees, I've got to use the 8 because it's given the hypotenuse. And if I'm going to find this X first, that's the opposite. So if I do the sine of 22.5, that's going to be equal to X over 8. And in order to find out what X is, I'm going to multiply both sides by 8. So 8 times the sine of 22.5 is going to tell me that X, which is representing half of our side length, is about, I got 3.06, I'm going to call it 3.1. That's this half a side length here that I'm pointing at. If I go and double that to get the side length, that's going to be 6.2. Take my half a side length, double it. Now, if I go into my triangle and replace this X with 3.1, what I've been saying is stick to what you know to find the apothem. How about a squared plus 3.1 squared equals 8 squared? That's going to be 64. And again, there's multiple ways to get at this answer. 64 minus that 9.61 leaves me with a squared is 54.39. And when I take the square root of that, I get about 7.4. Now, all that to find the area. Area is equal to 7.4 times 8 times 6.2 all over 2. And it's leaving me with an area of 183.52. Geez, do I have units here? 8 units. So they just said 8 units. This is just going to be in square units then, because it's the area of our octagon. A lot going on there, and when we get done going over this review, we're going to practice a couple of more of those lengthy area problems on our 11.3 that we didn't get through yesterday. All right, number 9. What are we dealing with next? Number 10. Oh, I can do that. Well, I'm already working on line paper. Put it here. Say it again? I finished with 183.5. Tell whether the solid is a polyhedron. Number 10 is not a polyhedron. And actually, you guys on your test, rather than naming, you have to explain. There are semicircles, which are quarter circles for faces, isn't there? There are quarter circles for faces. And faces must be what? Polygons. Quarter circles aren't polygons. Polygons are our triangles, quadrilaterals, and so on. Number 11. This is a polyhedron. It's solid. All of its faces are either triangles or, what's the base? 1, 2, 3, 4, 5, 6, 7, 8. An octagon. This is an octagonal pyramid. And what I'm going to say about why this is yes, which is more important, it is solid and all faces are polygons. Number 12, that one's going to be yes. Say the same thing. If you wanted to name it, it's a pentagonal prism. Prisms and pyramids are named by the shape of their bases. A pentagonal prism. But again, I'm more interested in why or why not something is a polyhedron. Pentagonal prism. Now in number 13, this sketch, I'm not requiring you to sketch on the test. On 13, I'm going to do it right on the paper. And I'm turning my paper because we've got to imagine, and I think in my classes, I did a pretty decent job yesterday helping you guys, even if you were struggling to visualize this, kind of helping you figure out how to get at it. This is two cylinders on top of each other. It's two cylinders on top of each other. It's a cylinder with a radius of 6 on the bottom, with a cylinder of a radius of 3 sitting on top of it. So sketch it, identify it, and describe it. It's two cylinders, cylinder with radius 6 on bottom, a cylinder with a radius of 3 on top. You are not going to have to sketch this. No, you are not going to have to sketch on your test. Number 14. If you are kind of getting the idea about drawing these, great. It's not something that I'm, is a exit skill or anything for geometry class. Number 14. The two white triangles. White congruent triangles fit into the blue circle. The blue is the shaded part. What's the area of the blue region? Well, the one thing that I had to do is stop and think and go, okay, well, wait a minute. What's the area of, if this radius is 3, what's the radius of the big circle? It'd be 2 of those. Yeah, so the bigger blue circle, so what we've got to do is we've got to take the big blue area, and from that we have to subtract the 2 small white circles. So if I figured out that the radius of the big circle must be 6, big blue circle then is going to be pi times 6 squared. That'll be 36 pi's. You guys okay with that right now? About 99 or 100. Let's just leave it right there for right now. Big circle is that. Small white circles are both going to be pi times 3 squared. So that's 9 pi. But there's 2 of them. Check me out. What's 36 pi minus 2 of these 9 pi's? Well, that's 36 pi minus 18 pi. That's going to be 18 pi. You see, I'm just counting pi's. Now I can go and say, what is 18 pi? In the end, final answer is going to be that the area is about 56.5 square meters. About 56.5 square meters for that one. If you had gotten decimals all the way along, like, I was just sort of simplifying things and using it that way. If you had gotten decimals all the way along, you should have landed right around there. My answer is going to be more exact because I left the pi's in there all the way through, but if you got something close to that, you're fine. And at this point, I'm sitting on 20 minutes. I'm not testing you on a question like the last one, so I'm going to stop this here, and my phone is ringing.